Hi, good morning. Big crowd on the last day. So we're talking about building AI pipelines on Kubernetes. My name is Susan Wu. I'm a product manager. I'm in cloud networking. And I'm going to let my esteemed panelists introduce themselves. Lou, go ahead first.
Hey everybody, I'm Lou. I'm the database engineer at LanceDB. So I built a data platform for Spark Presto previously, and now I'm building the data platform for AI agents and foundation model companies.
Yeah, hi everyone. My name is Ian Chakares, and I work in GKE. I've been there for 8 years at Google. And I did a bunch of work in open source Kubernetes before. I actually got to work on like how we do stateful applications and persistent volumes and persistent volume claims. But once I joined Google, was really focused on how do we operate these clusters really at scale. Single clusters at scale, many clusters, entire fleets of applications. How do we get them all to work together? How do we do it reliably? How do we do it in a performant way and obviously a secure way? About 4 years ago, I spent 2 years in Google Search, and I wasn't really expecting what happened, but I think that it was the LLM moment. And so I had teams already working on traditional AI ML workloads, but I got a firsthand look at, all the things that we would do with LLMs. I got to launch the initial products, Search Generative Experience, now AI mode. I also launched like Search Labs. I launched things on mobile like Circle to Search, which is really amazing. You can circle anything on your screen and search for it. And I had teams that were really focused on these new AI ML workloads and working on things like how do we prevent regressions and detect them before we roll out new models. And this is not only functional regressions, like it didn't do what we wanted, but also performance regressions, which are really important. And super scarce resources. You can imagine how scarce TPUs would have been in those days. And again, like we weren't able to do things, massive improvements in both the way we use the hardware and the hardware themselves over the last few years, and also develop best practices for how to use AI ML, both for the developers and the AI ML ops workloads. Then 2 years ago, I returned to cloud and to GKE and have been focused on GKE networking. And the networking space is really exciting. I'm looking forward to talking with you about it today. I'm involved in lots of things related to AI ML, like all the new accelerators and all that new hardware, GPUs, TPUs, the fabric between them. Things like DRA-Net, which Antonio did a keynote on this morning, which is about an intent-driven way to express topology and constraints for your applications. And also things like GKE Inference Gateway, which is intelligent routing for LLM traffic. So I'm Ian, and it is great to, I'm really looking forward to talking.
We'll have a lot of questions for Ian. Lucy, go ahead.
I did not prepare an intro that's that long, but we'll go for it. So hi, I'm Lucy. I work in platform engineering at Uber. My role started more defined on the stateless platform, but over the years has basically become a more undefined one. So I touch stateless, stateful, AI/ML, HPC, sometimes batch, and sometimes the core layers that sit underneath this. Within Kubernetes, I'm one of the leads on the Node Lifecycle Working Group, and within both Uber and my role in K8s, my life is increasingly taken up by AI, ML, and HPC workloads.
Okay, thanks, Lucy. Thanks, panelists. So let's dive right in, and we'll give it a few more. We have some prepared questions, but later on, feel free to go to podium because I'm sure you have your individual questions and you want to ask the panelists. So let's start right in. So you hear a lot about Kubernetes being like the platform for container orchestration, but now you're hearing, especially at this conference, for AI ML workloads. And so what's going on? What's happening in AI ML workloads that makes Kubernetes the right place to deploy your application and build your applications? I'll start with Ian on that one.
Yeah, sure. Actually, I'm going to tell you about maybe how is AI ML different from what Kubernetes did traditionally? And I'm going to talk about 3 different kinds of things today. The workloads themselves are really different. The scale at which we're trying to operate things are really different. And then we've got all this specialized hardware. So on the workload front, We've shifted from like, we have all these microservices, we're just trying to bin pack them onto VMs, and they're all stateless, to now we've got these, AI workloads like training and inference. These are stateful, they are massive, they consume all the resources usually that are associated with the hardware that they are given. Very expensive. They often interact across multiple different devices and kind of collaborate with each other. And also we even have now we've got reinforced learning, which is like a combination of both training and inference. So the workloads themselves are really different. And Kubernetes has to kind of adapt over the last few years to that. The next one is scale. So maybe 4 or 5 years ago, GKE had announced you can run 15,000 node clusters. And I think everyone was like, who in the world wants to run 15,000 node cluster? Or if you are, you're kind of crazy. But a year ago, we actually announced you can run 65,000 node clusters. And actually just in the last week or so, we've announced you can do over 100,000 on GKE. We've done over 100,000 nodes. So the scale factor here is not just 2x or 1 or 2x. We're talking about 10x kinds of numbers on the scale situation. And then finally, the hardware itself. Again, the GPUs and TPUs are just very different from CPUs. And as an example, on GCP, we recently announced the GB300s would be available from NVIDIA and the Ironwood TPUs from Google. And this hardware is just, crazy. And it has so many different special capabilities that really, in order to take advantage of it, Kubernetes needs to become a lot more aware.
Quick show of hands, how many folks are using the GPUs? How many are using? Oh, quite a few. Okay, good. I ask this question almost every time because more and more hands come up. Anyone using the TPUs for training? Anything? Thank you very much. Okay. So I have another question actually for Lucy a bit here. So there's a high dependency of GPU to run underneath the Kubernetes clusters. And I actually have a lot of customers that are worried about stock out. I am also doing a benchmark where I'm hunting for GPUs underneath my Kubernetes clusters. And we've been looking quite a bit. So for, we used to think of Kubernetes like cattle. But I think now we have to think of them as pets, maybe like that beautiful little puppy that you get during Christmas time. But anyway, so how should we think about that? At Uber, you run millions of cores, right? So how do you think about that?
We run millions of cores. Kubernetes is my puppy already. I think at KubeCon NA, we really, as a contributor community, committed to evolving Kubernetes to be the next home of AI, ML, and HPC workloads. And there's been a lot of foundational work across SIGs over the last year to make that a reality. A lot of features like in-place pod vertical scaling, in-place container restarts, and now we're looking at things like much better scheduling for AI, HPC, and ML workloads. I think that in the past, a lot of the challenges we see with HPC, AI, and ML workloads are also challenges we see with stateful workloads. There are a lot of properties that are both desirable to both. I don't want to disrupt a database sometimes. In the same way, I wouldn't want to disrupt a non-checkpointed training job, right? And of course, Kubernetes comes from a world of, we started with let's run a web server on it. That was like one of the first workloads. And a lot of those Arch decisions started and were based around that. We're starting to get to a place that I would say we're more confident running these stateful workloads with new APIs like eviction request, which helps you, for example, take a checkpoint of your training job before it is spun down, and with things like in-place restarts, gang scheduling, I think it's going to be quite important. We've really tried to, in the at least contributor community, lean into supporting both Ray and Slurm, and those are strategically important to us. I think there were quite a lot of contributors at the Ray Summit recently, which was great to see. And we've had a lot of interaction with the Ray and Slurm communities to talk about what are we missing in K8 that could be better for everyone here. And over the next few releases, 1.3.5, 1.3.6, I think we're going to see a lot of that stuff get betas and GA'd. So finally, it will be in all of your hands, which I'm very, very excited about, honestly.
Okay, it makes sense. Let me ask you another kind of follow-up questions. People are building data planes on top of Kubernetes, and so some of these extensions for serving, inference, and training. So, Lou, do you have any input on maybe how you've pushed how your company has pushed the envelope to innovate on top of Kubernetes for AI/ML workloads?
Yeah, so we are a pretty small startup, which is Series A. We build a multimodal lakehouse, which basically is a data storage that can store like videos, images, embedding all kinds of data. And we have the compute like solely on the Kubernetes. So your data part is sitting on cloud storage, and all the search engine and other things are sitting on top of Kubernetes. And really thanks to all the Kubernetes features, our compute is stateless, which means that if you have more search requests, we just launch more compute. And all our customers or users, they are the AI agent companies like Harvey, the biggest law AI agent company, and also like the foundational model company like Runway, etc. So they actually build on top of Ray and PyTorch and all those like popular like AI frameworks, which already have the Kubernetes deployment option. So it consider like their AI infra is actually pretty complicated, but everything is sit inside one Kubernetes cluster. So you have Ray, PyTorch, VLN, and other different frameworks. You have like LanceDB to be your search agent, and you have like underneath like cloud storage for your data store. So everything just like pretty isolated, but also connected to each other.
I think Uber similar tech stack, right, over there, right?
Yeah, we're very heavy Ray users right now. We use it for, what was it? I've lost my train of thought. Yeah, we run a huge amount of Ray, and we use it to scale our offline ML pipelines. The recent news of Ray joining the PyTorch Foundation was quite exciting. It really shows as well how AI, ML, and HPC is starting to converge on Kubernetes. Ray gives you the distributed execution. PyTorch gives you actually running the thing. And yeah, I think this actually shows that we're going in the right direction with K8s now. I mean, what's the word? That's the word. I've lost my train of thought again. What I was going to say, yes, that was it. I think it shows how we're going in the right direction with Kubernetes. The fact that Ray is starting to really be leaned into, and how Ray is running on top of K8s.
I saw that. Your Michelangelo project, I took a couple of screenshots. I saw was running PyTorch, Ray. Can't remember the rest of the stack, but
very big stack. About hundreds of engineers working on
stack.
it right now.
Mm-hmm.
Yeah.
Yeah. So I think you might have seen a lot of multimodal models. People are building, applications on VO, Flow. Because this is not only text data, how do you build pipelines for data that's spanning like audio, video, and all that?
Yeah, so unlike like Ray, PyTorch, they are kind of like dominating the compute kind of side. But on the data side, you can see so many solutions. Like if you want to, especially like AI agent these days, they have so different like data retrieval needs. Like you may have like Elasticsearch to like do the full text search of your test data. Like if you want to search like a lemon dessert, then you put the keyword there and then search the recipe that with lemon dessert. But nowadays people also like use some vector database for semantic search, which like just like the I sometimes call it vibe matching. Like you search, you don't know what you want, and then you can't put in your feeling and then do some vibe searching, which human brain and model can understand, but you cannot really use some traditional way to extract the data that you want. So all those different retrieval needs kind of result in different systems, and which results in like your data are actually sitting in different places, like your cloud storage, like different kind of database. Like for example, if you want to run SQL, you have a SQL database. So we try to make everything like become the standard. Like so we built something called the Lance format, which is an open source multimodal format that you can download all your image, video into cloud storage in that table format. And we already directly support all kinds of search, like full text search, SQL search, vector search. So you don't need different solution for different like AI retrieval. And the same data set can also be using for training, for feature engineering, etc. So it's like we are basically the open source standard for multimodal data. And we try to unify the data part to make the architecture easier. So you are not just like unifying the compute for Ray and PyTorch, but also use the Lens format to unify the data part. And we are also in the process of donation to the foundation.
Wow. Okay. So let's switch gears a little bit. What are some of the infrastructure considerations that you should have when you're running these AI workloads? You saw in the keynote the DRA net, and some people have been talking about the inference gateway. Can you take a little bit more on that, Ian?
Yeah, I'll talk a little bit as a person in networking. I'll tell you about some of these innovations when it comes to networking. And again, most of these are by vendors or really based on open source technologies. And they're fundamental to how we're doing things in Kubernetes. So the first one is these accelerators and the networks that attach them. They're not just like a single interface and, let's say operating at a few gigabytes per second. Now we have these really intelligent fabrics that interconnect like multiple devices within the same chassis, multiple different chassis within a single rack, between racks, between rooms, between data centers. And every one of these links needs to be extremely high capacity, low latency to deal with the AI ML workloads. So for training, this could be like you're just pulling in your training data. Again, really high network usage, or storing your checkpoints, which you need to be doing quite continuously as well. Or for inference, like we're now talking parameters in the Tera era, and which is hundreds of gigabytes to just pull those models in and make that happen really quickly. So that's one, is this fabric that interconnects everything is really fun from a networking perspective. The second one, you talked about DRA net. We recently announced that on GKE, we have a managed DRA net offering. And what DRA net lets you do, as opposed to like, you could just say, just give me an accelerator. Now you can say, in a Kubernetes-oriented fashion, you can say, I want an accelerator and I want a NIC, and I want those two to be on the same PCIe bus. And again, Antonio showed it in the keynote this morning. You can get like a 60% performance improvement by having that type of alignment. And this has to go through all kind of levels of the stack to really achieve that really high performance. Understanding not only what the workload needs, but what the topology and the hardware has to offer. And then finally, you mentioned inference gateway, or GKE inference gateway is the one that's supplied by us. This is an intelligent L7 routing for requests for LLMs. And again, traditional load balancing, just kind of spraying or round robin, isn't really appropriate for this type of use case. You need to route things intelligently. So that could be like, I want to route this particular model to this particular node or set of nodes. With LoRa, as an example, you might have different versions of the model on different nodes. You want to send it to one that already has it, or be aware of the prefix routing or the KV cache utilization, right? If you can avoid doing work and just send it to a node that already has a lot of the work done on it, then you can not improve efficiency, but decrease latency. So like time to first token could be dramatically reduced, or the overall efficiency of your hardware could be improved. Again, you can do load-aware routing, where you're not just how many requests did you send to somebody, but maybe looking at how big were those requests from an input or an output perspective. And also doing things like criticality, or the priority of that, to load shed. If you have something where somebody's waiting for something versus a batch, you could prioritize those real-time flows. So again, lots of really exciting things happening, whether it's in the fabric for networking, whether it's about expressing your intent around networking to achieve high performance, or whether it's around routing these LLM requests.
Yeah, so AI is all about performance. Yeah. So, please do. I was about to say the DRA net is actually not only for GKE. You could be running any, because it's donated to CNCF.
Because we are dealing with the data, so network is one part that's really important. So sometimes like our our load, basically we need to get the data super quick in a really high operation per second. So sometimes it crashed the Kubernetes network. We haven't crashed the GKE yet, which is really good. So we really rely on the GKE to provide us like really stable network between nodes so we can serve the data quick enough to the applications. So we do crash some of the network, but not GKE.
So I have a question about network agents, but before I do that, do folks have questions that they want to go to a podium? Yeah, go ahead first before I ask about the building network agents or agents in general.
Thank you.
Yeah. You could use this one then if you want. Go ahead, use this one.
Okay, yeah.
Okay, this is going to solve it.
Thanks,
Yeah,
Dave.
thank you. So my question is that if you take a look at a standard machine learning pipeline, so you have dev test, then you have a place to store your train model, and then you have your inference, right? That's the standard path. My question is on dev test, not on the inference paths, right? Where you don't have scale so much as you have velocity, as you need velocity for multiple devs to come in and test really fast. And we have found that Kubernetes can also lead to some challenges there. It's like, much more expensive, much more clumsy for data scientists and MLEs to go in and spin up these instances really fast. And then many of them don't shut it down once they are done with their tests because they don't get GPUs, right? I mean, once they got the GPU, they want to hold on to the GPU and they don't want to give the GPUs away. So it's more of a question of velocity and ease in the dev test as opposed to scale, like it's on the inference side. And we are looking at a solution called DStack. I don't know if you have heard about DStack. It is specifically built for AI/ML workloads. It's an orchestrator as well, just like Kubernetes is, but it works a little differently than what Kubernetes works on. So question to Ian is that has Google looked at DStack at all? Has Uber looked at DStack at all? And is there a plan to sort of support DStack also as part of the GCP later on, just like you support Kube? Thank you.
Putting you on a spot.
We should have a chair for him here.
I'm not familiar with DStack, but I will say, like Jago gave a keynote yesterday, and one of the things around Kubernetes and obviously GKE is we want to integrate with the frameworks that do orchestration. Kubernetes is about orchestrating infrastructure, and so all of these frameworks for AI/ML, we want to have them work really well in Kubernetes and obviously on GKE. So I think, again, like someone may be looking at it. I'm not. I'm really focused on the networking side. I think for the other part of your question about, let's say, dev, test, and these different environments, I think Kubernetes is a great place to do dev test and like share among many different people. I'm also seeing kind of starting to come down the pipe is more about fractionality of use cases. So this would be a different way to slice your infrastructure and use your infrastructure that maybe is larger than whole nodes in some ways. And so that might be a future kind of thing that's coming down the pipe. And then obviously for your devs, right, or for the researchers, then you can give them slices. And I'm guessing that, if you're not using all that infrastructure, that's a different problem. But at least maybe in terms of controlling how you use that infrastructure and using it in a more effective manner, but still giving high velocity to people who need it. I think, again, we're probably all learning about how to do that phase of the life cycle as well, not just the mega scale.
And I am not the Kubernetes expert that much, but for us personally, we basically use Ray plus like auto scaling node group to achieve some of those like dynamic resource allocation and shut down the pods when we don't need it and launch the pods when we actually need to run some AI workloads. So we use it in a naive way comparably. But yeah, that's the usually, I think that achieve a lot of like requests from the AI agent side, from the feature engineering side, and from the training side.
Okay, I'm going to switch gears. I meet a lot of customers that are actually building agents. There was I think a company here, Salesforce. They build a lot of agents, and I do know that Uber also, and I don't know if there are other folks here that are building agents. So what's happening is, how are they doing? How are they extending Kubernetes to build agents? They talked about it, but maybe perhaps Uber. How are you doing that?
Yeah, so we already have a lot of AI/ML workloads that we've had in our system for a while. So matching, pricing, ETA, and those run as stateless workloads. But especially agent and agentic workloads, they're stateful and interactive. So we've had to take a slightly different path with them. We define them as CRDs within our K8 stack and with their own controllers. And then we built this pretty large now MCP gateway to let them interact with our internal tooling. A lot of that right now, especially, is dev focused. So it's like, can it see the internal source code? Can it see like PRs and stuff you're making? And so we've had people experimenting with building agents on that system for a while. We effectively give them the foundation of, you can make an agent, you can give it internal tools, and it's up to you. But then we don't want everyone just building in isolation. If you make something really cool as an agentic agent, we want to take that back centrally and distribute it to everyone. So we have an internal registry of agents. It actually has like a popular list and things. So that if you build like a really cool agent for like working on an internal part of the Uber code base or something, other engineers can see it and go ahead and use it and give you feedback and rate it and so on. And then we are also have, of course, a lot of the performance fun of trying to squeeze out every last bit. And especially, I'd say, it's quite interesting in that before, it was only really HPC people who really seemed to care about this stuff, and a lot of them were not on K8s. Like, you'd try and find an HPC on K8s, there just wouldn't be any. But now suddenly HPC is everyone's problem, especially when models now are so big you can't even fit them on a single blade in a data center. So we have our own thing called the federated scheduler. And what it does is it effectively tries to federate Kubernetes clusters. So we have some on cloud, we have some on-prem, but just like you mentioned earlier, you want to place these workloads effectively together. Gang scheduling will solve this eventually, but for now, we have our own way of doing that with this federated scheduler. But that's a very brief rundown of like how we're doing agentic agents, and we have a whole internal dashboard and website where people can go and discover like, hey, here's this agent for like helping you write code for this, or hey, here's this agent for helping you explore this data set or something.
Yeah, on my side, we see experimentation. So we had a hackathon, and over the weekend, people just pull the ADK and put together some agents just to reduce toil, kind of operational kind of things. We had one person develop some agents to kind of automate looking up different workload availability and look for where some of the GPUs are. So I asked them I'm looking for some GPUs right now. And I look in Korea, and I haven't found it, but they had the agent that you put that to work. So there's a lot of experimentation out there. Are folks experimenting? Any show of hands? Anyone experimenting? Yeah, okay. Yeah, feel free to go to the microphone and tell us what you're building. It's kind of interesting. A lot of experimentation going on. With that, do you have any questions? I have a bunch of prepared questions, but I think we pretty much kind of talked about that. Anybody with individual questions that they want to go to the microphone and ask? Nobody?
I'll give you an Uber discount code. No, I'm kidding, I won't.
Last chance to find out how they build Uber.
Then maybe give you folks more time to prepare for that. And then also I want to talk about agent because one of our customer, Harvey, which is the biggest law AI agent company. So they actually build the agent the logic in Python, because Python you can grab which model you want. You can decide what data you want to retrieve from LanceDB, multimodal layouts, and then you combine all those logic into some predefined way. So agent is just a chain of operations, if you really consider that. Maybe with some model intelligence inside, but it's just a chain of operations that you can define in Python script. And then you can throw that to a node in the Kubernetes. If you have more requests, you just scale more nodes. So it's nothing that fancy, agent.
Yeah, I'll chime in a little on the agent front, maybe from a networking perspective, right? We've got all these new protocols for how they communicate with each other. And I wouldn't say there are challenges, but there are definitely some differences there. I'll mention a few of them, like authentication, authorization of these things. These things are doing things on behalf of other users. So that's obviously really important. Another challenge in this particular space is that observability. And I think when you move to multimodal, it also gets even crazier. So knowing what are these agents doing, and then also storing that information. And again, trying to keep them more stateless, the agents themselves. But obviously there is state, and maybe even big state, that you don't want to move around, let's say, in those protocols. So linking out to them, and then again, logging to understand what in the world they're doing, whether that's the user of the agent wants to know what in the world happened, or what did they actually do, or a platform team or a company itself really understanding what happened. So lots of fun things kind of on the network front when it comes to agents.